I would like to show you how to draw the Lewis structure for HNO3, or nitric acid. The first step in drawing a Lewis structure is to draw the way you think the atoms are bonded together. In this case, nitrogen will be at the center. The way that we can guess that is that with polyatomic anions, the oxygens are very rarely at the center. Hydrogens, when in acids, are usually bonded to oxygen. So watch this. We will put the nitrogen at the center and surround it with the 3 oxygens. We will bond hydrogen to one of the oxygens, it doesn't matter which one, and try this structure out. How many valence electrons does this molecule have? Hydrogen brings with it 1 valence electron, nitrogen brings 5, and oxygen brings 6 each, or a total of 18. That means this molecule altogether needs 24 valence electrons. We always begin by placing electrons where bonds need to be. 1, 2, 3, 4, 5, 6, 7, 8. Before we add electrons to the rest of the atoms. Always add the rest of your electrons to the surrounding atoms first. In this case, we already have 8 electrons. Let's put down 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Each of the oxygens now, if you notice, satisfies the octet rule and has 8 electrons around it. Hydrogen only needs 2 electrons around it. It satisfies the octet rule like this as well. Nitrogen, on the other hand, still needs 2 more electrons to satisfy the octet rule. In this case, we prefer to move the electrons from an atom that is not bonded to something else. It's poorer form to move these electrons to be shared than it is to move, say, these electrons. Because the hydrogens here, these electrons are a little less mobile than the ones on this oxygen here. So let's erase those 2 electrons and add them in that bond there. Now each atom here satisfies the octet rule. Each oxygen and nitrogen has 8 around it, and hydrogen has 2. The final step again is to replace each of the bonding pairs with a line. I almost forgot that bond. And here we have the finished Lewis structure for HNO3.